Good evening. My name is Maxime Gagnebin, and I'm a research scientist for the Lisk project. And this evening, I want to talk to you about cross-chain messages, which are the last piece of the puzzle for our interoperability solution. We have seen so far the two large pieces, the chain registration and the cross-chain update, and this is the tiny piece that goes in the update, the message. So the agenda for today would be first looking at the format of the base message, which properties are present there, and then seeing a concrete example of a token transfer asset. And lastly, we will see the life cycle of this token transfer in the ecosystem. Okay, let's start with the format of the cross-chain message. In essence, a cross-chain message is a piece of information which is supposed to trigger a state transition on the receiving chain. And in that regard, it's very similar to a transaction. And if you're familiar with Lisk transactions, this will be familiar to you. We have an index, which is similar to the nonce on transaction, and this is used to guarantee uniqueness of the cross-chain message. This avoids cross-chain replays, for example. We have a pair of module ID and asset ID, which identifies which module this message belongs to, and also identifies the processing logic needed to apply the message. We have a fee. This fee will be assigned on the receiving chain to the relayer, and we have an asset, where you store custom data used by the module for the processing. And so far, those 5 properties are also present in transactions. However, cross-chain messages are sent from one chain to the next, and this information needs to be included in the message. And so we have 2 chain IDs, the sending and the receiving chain. And lastly, something that is, again, not needed for transaction, we have a status field and an original index. And those are used for error handling and message tracking. The reason being that the message, when it is created on the sending chain, doesn't know the status of the receiving chain. So it doesn't know if it will be successful or it will trigger an error. And so this is stored in this property. Lastly, you will notice that the message does not have a signature. The validity of messages is attested by the fact that they are included in cross-chain updates, and the certificate of the cross-chain update is signed by the validators of the sending chain. And so we don't need a dedicated signature in each message. This allows the message to be slightly smaller and hence a bit more efficient. All right, now let's look at a specific asset property for a token transfer. The token transfer is likely to be one of the most used cross-chain messages in the ecosystem. And logically, the cross-chain transfer message looks a lot like a token transfer transaction, where you have an amount, how many tokens are you sending, a recipient address, who is getting those tokens, and a data field. This can be any small message that you're sending to the other chain. Maybe hi, or those tokens are to pay for coffee. When you are sending across a token transfer transaction, the sender of this transaction is obvious because it's the sender of the transaction. However, for messages, this is not as clear because the message will be bundled up with many other messages to be sent to the receiving chain. And so we need to save the sender address as a specific property of the message. And lastly, and maybe most importantly, you need to specify which token you are sending. When you are on the Lisk chain, it's obvious that any token transfer is the LSK token. However, once you are in the Lisk ecosystem and there are many, many tokens flying around, well, you need to specify which token you are exchanging. Okay, and so this is all there is to a token transfer asset. And now let's see how this message would be created and transferred in the ecosystem. First, you want to create your cross-chain message. So you have one transaction which says basically, I want to send 5 Lisk to my friend Bob on chain 17. And this transaction will spawn a cross-chain message with exactly this information. You can see here you have the module ID, which is the token module. It's a transfer for the asset. It goes to chain 17, and it's 5 Lisk for Bob. This message then is handled by the interoperability module, which will complete all the remaining properties. So you don't need to send the index. You don't need to set the original status or the sending chain. This is filled in by the interoperability module. This message is then collected by a relayer and sent to the main chain. There, the main chain only checks 2 things. It checks, was the sending chain actually the one that is written in sending chain property? So here, sending chain 3. And is the message targeting the main chain? And here, that's not the case. So the main chain does not apply the message, but will forward it to chain 17 by creating a new message, which still has chain 17 as the receiving chain, but has a new index, but of course kept the original index. And in this regard, you can still find your message. This new pink message is then, again, included in a cross-chain update by a relayer. There, chain 17 remarks that it is actually targeting itself and opens the whole message, sees, oh, that's a token transfer, 5 Lisk for Bob. The status is OK, and so Bob gets his 5 Lisks. And that's the good case. Everything goes well, and every chain is available. But in an ecosystem of blockchain, many things can go wrong. And the interoperability solution that we are proposing comes with a whole zoo of error handling and management for those errors. So let's quickly see one possible error. When the message gets to the main chain, and the main chain tries to forward it to chain 17, it could be that this doesn't exist. And so the main chain, in that case, will create a new error message where you can see that the receiving chain is now chain 3. So it will be sent back to chain 3, and the status is changed to chain unavailable, indicating that there was an error. This new message is handled exactly in the same way as a regular message. It's included back into chain 3 via a cross-chain update. Chain 3 will open the message, see that it is a token transfer, and see that it has an error code. And so it knows that the message was unsuccessful, and the 5 Lisks are given back to Alice and not to Bob. And so the message was successfully returned to the sending chain, and everything is well. We have quite a few different error cases that are also handled automatically by the interoperability module. So to summarize, we are defining a uniform cross-chain message, which is flexible and efficient. It's quite flexible because you can choose whatever you want in the asset property, and efficient because we are only integrating what is necessary in the message. With this message comes a basic error handling, which means that as a sidechain developer, you only need to care about your custom logic and your custom behavior, and you don't need to worry about all this error handling. That's it from me. Thank you very much.